FET self-bias configuration using graphical approach. So where to find the quiescent conditions of our previous example using the graphical approach. So how do we do this? So the self-bias configuration graphical approach is determined by two steps. So first we are to define the points on the two for us to be able to sketch the transfer characteristic curve, and then next is we are to sketch the self-bias line for us to get the Q point of the circuit. So these are the important points for us to sketch the transfer characteristic curve. First is when our VGS is equal to 0, our IDSS will equal to, or our ID rather is equal to IDSS. So this will be our first point. Next is when our VGS is equal to VP times 0.3, our ID will be equal to IDSS over 2. So it will be somewhere here. And then, rather here, somewhere here, the second point. And then our third point is when our VGS is equal to 0.5 VP or VP over 2, our ID will be equal to IDSS over 4. So, and the last one, when our VGS is equal to VPIC, our ID will be equal to 0. So, connecting the 3 points, okay, for us to get the transfer or to see the transfer characteristic curve of the circuit. Then we are to sketch also the self-bias line. Okay, we will be able to sketch this self-biasing line by 2 points. First is from the origin 0, 0, and the next one is when our ID is equal to negative VP over RS. So this is from the equation VGS is equal to negative ID RS, where VGS is when VGS is equal to VP, our ID will be equal to negative of VP all over RS. So yeah. So somewhere when our VP, VGS, VP, so somewhere here. So the second point is somewhere here, and we will just connect the 2 points for us to have the self-biasing line. So the intersection of the transfer characteristic curve and the self-biasing line will be the Q point of the circuit. So the value which corresponds to the X here, the X value will be equal to the VGSQ, and then the Y value of the point will be equal to the IDQ of the circuit. So ayun. So going back to our, or taking our previous example, so we will need to determine the values here. Okay, when first is when our VGS is equal to 0, our ID will be equal to IDSS, which is equal to 8 milliamperes. So this is in milliamperes. And next is when VGS is equal to 0.3 times a negative 6, so that gives us a 1.8 volts value, negative 1.8, and then here is 0.5, and a negative 6 will give us a negative 3 volts. And for the last one is we will set our VGSQ equal to our pinch off voltage, which is a negative 6 volts. Now for our ID, the first point is that is equal to IDSS. Next is when our IDSS is half or divided by 2, so we have 4 milliamperes, and then next one is that should be equal to divided by 4, IDSS all over 4, so that gives us 2 milliamperes, and then for the last one, ID is set to 0. So we will locate these points in our graph. Okay, so first is 0 and then 8 milliamperes, so our first point here, and then next is negative 1.8, so somewhere here, and then 4 milliamperes, and then next is 3 volts, negative 3 gave us a 2 milliamperes, and for the last one, when our VGS is equal to negative 6 volts, our ID is equal to 0. So let's connect the points for us to see the transfer characteristic curve of the circuit. So here, so I'll just so here, so there. So our transfer characteristic curve will be like this, and now the next step is we are to sketch the biasing line, self-bias line, which is given by these points when ID is equal to 0 and VGS is equal to 0, and negative VP RS, and this gives us our VP equal to a negative 6 volts. So negative of the negative 6 volts over our RS is equal to 1 kilo ohms, so divided by 1 kilo ohms, our ID here will be equal to 6 milliamperes. So 6 milliamperes, negative 6 volts. So let's locate that point, 6 and 6. So ito yon. And then we will just connect the 2 points here. So from the 6, 6 going to the origin, so we will just draw a straight line. We are now ready to determine the quiescent point of the circuit. So let's see. So this is the Q point of the circuit. So this is a Q point. So let's see where it is located in the graph, and we will estimate its value here. So our VGSQ is equal to somewhere a negative 2.6 volts, and also our IDQ is equal to a negative, or no, that is equal to a 2.6 milliamperes. So ganon lang yung pagkuha natin. If we are to compare the values of the IDQ and the VGSQ obtained in the graphical approach, if we are to compare that with the calculated value here, here. So they are very close. Okay, they're very close. So we here in exact value, we have a negative 2.588 volts, and IBQ is equal to 2.588 milliamperes for the IBQ. So that's it for the graphical approach of a self-bias configuration.